Hello dear students, in this video let us understand how to calculate magnetic field due to an infinite straight current carrying conductor using Biot-Savart's law. So here in this picture you are having an infinite straight current carrying conductor. We are required to calculate the magnetic field at this point P, okay, from some origin O, okay, situated at a distance R, okay. So for that, what we are going to do is we are going to use Biot-Savart's law, and for that, and we know that to use Biot-Savart's law, we need to consider an infinitesimal current carrying element. So let us say the current carrying element dy, okay, which is carrying current in the upward direction, is situated at a distance y from the origin O, okay. Then we are going to calculate the magnetic field at point P due to this infinitesimally small current carrying element, and then we are going to integrate it across the whole length of the conductor to get the total field due to the whole length of the conductor at point P. Okay, so first we will see how to calculate the magnetic field at point P due to this small element dy by using Biot-Savart's law. Okay, so by Biot-Savart's law, we know that the magnetic field due to an infinitesimally small element dy at a distance, what will be this distance? Yeah, so if this is y, this is r, this is, let us say, this is my 90-degree angle. Let us call this angle as theta. So this, by Pythagoras theorem, will be r squared plus y squared, right? So at this distance, okay, at point P, at this distance, square root of r squared plus y squared, the magnetic field dBp due to the small, infinitely small current element will be equal to mu naught upon 4 pi I is the current that is flowing through the conductor in the upward direction, I dy, okay, I dy sine of angle theta divided by the distance where we are calculating the magnetic field. So that distance is square root of r squared plus y squared the whole squared. So this is the formula that we know, right? I dl sine theta upon r squared. So that distance is square root of r squared plus y squared the whole squared. Now we will just evaluate this further. Okay, now the things are like more of mathematics here. Okay, so mu naught upon 4 pi, okay, this will be as it is, current I is as it is. You just write that dy, and this part will become square root of the whole squared will be r squared plus y squared, right? And sine of theta, if you can see that, okay, in this triangle, sine of theta will be, okay, theta is here, so it will be opposite upon hypotenuse. So I can write that as r by square root of r squared plus y squared. So I'll just write that as r squared plus y squared whole raised to the power half. Okay, now we will just simplify this further. What will this become? If we simplify this, this becomes mu naught upon 4 pi I dy, okay, so this will become I r dy, yeah, divided by r squared plus y squared whole raised to the power 3 by 2. So this is 1, this is half, so it will become 3 by 2. Now to evaluate this further, okay, this particular function, we have to take something, we have to assume something. So let us, I want to integrate this, right? So BP, the total magnetic field BP will be integral of the length is this y is going to range from minus infinity to plus infinity, okay, of dBp, right? Due to this small element, whatever is this magnetic field, we have to integrate it across the whole length of the conductor, minus infinity to plus infinity. Now in order to do this integral of this function, what we are going to do is we will assume y is equal to r tan theta. We will say y is equal to r tan theta. So if I just take the derivative of this becomes dy is equal to, yeah, r sec square theta. Okay, I'll say y is equal to r tan theta, so this will be I sec square theta d theta, right? Now I want here, okay, I want here r dy. Okay, so what I will do is I will just multiply r here. Okay, so this will become r squared sec squared theta d theta. Now I can just plug that in here in place of r dy, right? But now you know that when we are assuming something in a function, okay, the limits of the function are also going to be changing. Okay, so y is a function of theta, so if y is changing, theta is also going to change. So here the limits of y are minus infinity to plus infinity, right? So if I say if y is equal to minus infinity, yeah, what will be theta? Theta will be minus pi by 2. And if y is equal to plus infinity, yeah, limits are what? Minus infinity to plus infinity. If I take y is equal to plus infinity, theta will be equal to pi by 2. Now how do you get this? You know the if you want me to recollect this, yeah, so you know that the function tan theta, right? The function tan theta is basically like this, right? This is minus pi by 2, this is plus pi by 2, right everybody? This is tan theta function, yeah, tan theta function. So theta is, when theta is minus pi by 2, the tan theta function is at minus infinity, and when theta is pi by 2, it is at plus infinity, right? So that's why if y is equal to minus theta, theta will be minus pi by 2. If y is equal to if y is equal to minus infinity, theta is minus pi by 2, and if y is equal to plus infinity, theta is plus pi by 2. Now we can just plug those things into the integral, and what we are going to get here is, so this dBp, okay, or I'll just write this directly, Bp, the magnetic field at point P due to the entire length of the conductor will be integral, and now I have changed the limits, right? I have to change the limits, so it will be minus pi by 2 to plus pi by 2 mu naught upon 4 pi I r dy. What is r dy now? It is r squared sec squared theta d theta. I r squared sec square theta d theta whole divided by, this will become r squared plus y squared in place of y squared. So y is r tan theta, so it will be y squared will be r squared tan squared theta. So that will be r squared tan squared theta whole raised to the power 3 by 2. Now if I evaluate this further, this will become minus pi by 2. Okay, I'll just take that mu naught upon 4 pi out, so it will become mu naught upon 4 pi, yeah, minus pi by 2 to plus pi by 2, yeah, and this will be r squared if I am taking out from here, okay, r squared raised to the power 3 by 2, so r squared raised to the power 3 by 2, this 2 and 2 will go, right? So what am I going to be left with? R cubed, yeah, so it will be I r squared sec squared theta d theta whole divided by r squared has come out. When I am taking r squared raised to the power 3 by 2, it will become r cubed, and this is inside the bracket. I will be left with 1 plus tan squared theta, right, whole raised to the power 3 by 2, correct? Now once we have done this, the things are becoming even more simpler now. This r squared is going to be cancelling with this, yeah, and here we are going to see mu naught upon 4 pi, okay, integral minus pi by 2 to plus pi by 2, and that will be, what is that? I sec square theta d theta, okay, into divided by r into, what is 1 plus tan squared theta? We know the trigonometric identity, that is sec squared theta, yeah, so that is sec squared theta again raised to the power 3 by 2, so that will be sec cubed theta, right? Now here I am having sec squared theta and here it is cube, so that will also go. Yeah, so what am I left with finally? I can see that things have become very, very simple here. Mu naught upon 4 pi, this r I will take out because that will be constant. That current I, that is also constant. Okay, that r distance is fixed, right? In the diagram we have seen that. So minus pi by 2 to plus pi by 2, and that will be simply 1 upon sec theta d theta, and 1 upon sec theta, you know that it is cos theta d theta. Yeah, and once we have got this, we can quickly evaluate this and get the final answer. It will be mu naught I by 4 pi r, and this will be cos theta integral is sin theta. So sin theta, it will be, limits will be from minus pi by 2 to plus pi by 2, and this when you evaluate further, what you're going to get is mu naught I by 4 pi r, and sin theta, okay, sine of upper limit you substitute, sine 90 is going to be 1 minus sine of minus theta, that will be minus 1. Yeah, because that's sine theta is an odd function, so that will be minus 1. So what you are getting is 1 minus of minus 1, it is 1 plus 1, that is 2. So this will be mu naught I by 2 pi r. Yeah, that 2 and this 2 is going to get cancelled. So the magnetic field at point P is nothing but, it is simply mu naught I by 2 pi r. Okay, so that's the magnetic field due to a straight current carrying infinite conductor. Thank you.